In lesson 3 here of module number 3, we're going to have a look at containers. Now, many of you who are watching this have had some experience, certainly, with the operational workflow that many call DevOps, where your developers are coding and then pushing their code into production, right? The operational part of it, that's our job, is to make sure that the containers themselves, or really the applications that we're working with, have the resources that they need, have the security they need, have the redundancy they need, and those sorts of things. Well, what does all of this have to do with vSphere? What does all of this have to do with ESXi and vCenter Server and virtual machines? Well, recently, VMware has, with the release of vSphere 7, integrated containers and a management orchestration tool called Kubernetes into the vSphere product itself. And as these tools become more and more ubiquitous, as they become more and more widely used throughout the industry, it's important that we as vSphere architects and administrators understand the concepts behind containers so that we are able to embrace this technology and bring it into our environment. So that's what lesson number 3 is all about, is really understanding these concepts of containers so that we know what to do with them when we're finally asked, hey, can we handle this DevOps? Can we handle this modern application architecture? Okay. So what we'll do here is we're going to have a look at the benefits and the use cases for containers. We're going to look at the container system and all of the different components that go into operationalizing containers. And then we'll have a look at the difference between containers and virtual machines and see that from our perspective, from the vSphere administrator perspective, they're not quite so different. Now, whenever you hear the term DevOps and you think the developer is involved in the operationalization, boy, that's a big word, in the operationalization of their code, you think of in what method is this code actually developed and then deployed. And we have a couple of different terms that we use to describe this. Traditional application development, we use this term waterfall development for this type of applications. vSphere, by the way, and vCenter Server at VMware is developed with the waterfall development lifecycle. What does that mean to us? Well, at VMware, we know that as we hand this code, if you will, off to our customers, that's all of us that are using vSphere, that it gets deployed in the data center. And from that point on, from the deployment on, VMware has absolutely no ability to affect things like patches, things like upgrades. All of that stuff, that's on our vSphere administrators to actually do. So if there are problems with vSphere, boy, we here at VMware have an issue. We have an issue with making announcements of conferring information to all of us vSphere administrators to say, hey, we've got this patch, it's a security patch, it needs to go in right away. Please do X, Y, and Z. You may have to take an unplanned downtime. You may have to reboot your ESXi hosts, all of those sorts of things, right? So in this world where the developers, VMware, have very little ability to affect the operation of the environment, we use waterfall development. And we're very, very careful about the code that we release, that it's tested by many thousands of people, and that sort of thing. We also find in this environment that these applications are relatively monolithic. It means it's one component. We install this application, and the application does everything that we need to do. We may have a database or something like that behind it, but for the most part, the application gets installed and all of the components of the application are built into one sort of apparatus, maybe a virtual machine, for example. Okay? When it comes to deploying upgrades and things like that, we're also very careful about it. We'll have a staging and a testing environment. From the testing environment, we'll bring it into a staging environment, and then finally push it into production when we're really, really certain that there won't be any issues as we go into production. And if those three environments aren't identical, staging to testing, or testing to staging to actually then production, then we might have some issues. What was different between the production environment and the testing environment that prevented us from capturing this issue that eventually occurred, right? So we're really, really careful when it comes to these sorts of applications and the way that we deploy them in our environments. Now that stands starkly in contrast with more modern application development, which we might consider or use the term agile development with. Okay? When we have agile development, we might choose to bring containers into the environment and divide our applications into lots of different components. We'll call those microservices. We'll have components that do separate components that do each of the different jobs that the application might require. That way, as we are, say, pushing updates, live updates into production environments, if there's a problem, all we have to do is fix the component that has that problem. It's not an environment where you're taking a piece of software and then delivering it out to lots and lots of customers for them to deploy in their own environments. No, it's typically think of like an Apple or iOS app or an Android app where you push some component out into the Play Store or the Apple Store, and updates are automatically deployed to your end users and things like that. If there's a problem with the application, hey, I can just hit a button and push a new app out. Or if there's a problem in the back end for that app, I, as the person that's running that back end, can just replace that component. So we'll use little components, we'll divide them up into what we call microservices, so that we can affect changes in just parts of the application, hopefully without affecting other parts of that application. And that really speeds our time to delivery, to market. It allows us to say, hey, you know what? If there ends up being a problem with the application, as we discover the problem, we'll fix the problem, right? VMware can't just do that with vSphere. Most organizations can't just do that as they're developing an application, handing it out to their users, and then asking them to deploy it in mission-critical infrastructures, okay? But with agile app development, this is actually what we're talking about doing. It allows us to then to deliver those updates. Now, when we, very quickly, but as we do this, of course, as we go really fast and we're developing applications and then putting them into production, right? That's our job, is to put them into production. And then to operationalize those later by providing networking and security and making sure there are enough resources and all that kind of stuff, right? That's our job. We actually have some significant increased risk that bugs in that application, bugs in the scalability, or unknown issues might occur that we'll have to jump in and fix right away. But with these sorts of components and with containers and this system or architecture around containers, we're actually able to do this really quickly. So there are a lot of benefits then, of course, to building our application into separate components, microservices, if you will, and containerizing those applications. Okay? If you look at the left-hand side of this slide here, where we're describing a monolithic architecture. What we see is a load balancer in front of our applications, because we do have to scale our applications at some point, right? And if one virtual machine doesn't do the job, well, then maybe 2 or 3 or 4 or 10 or 100 will do the job, putting a load balancer in front of them. But noting that within that virtual machine, the entire application is contained, right? If in, for example, an e-commerce application, I'm going to have a UI for the end user to come and visit. I'm going to have an ordering system. I'm going to have a user management system. I'm going to have a product management system. And all of these things will have a database behind them in a single database. So all of these components then are in one set of applications. They run in a single virtual machine, right? As we scale, we add more virtual machines, but they all sort of do the same thing, right? But if we have to replace any of these components, if we have to update any of these components, we have to update the entire application, not just little parts of the application. And that's where, in a microservices architecture, we have some advantages. We have the advantage of saying, you know what, the user interface needs more resources, but the rest of it is doing fine. So let's just scale the user interface by adding more virtual machines behind the load balancer. Typically, we'll have an API so that the user interface can talk to the rest of the infrastructure to call those sorts of components as needed, to call the user management system or the order management system and those sorts of things in this particular case. We'll have separate databases behind those. So if we need to update the user management system, we can simply update the user management system without affecting the rest of the operation. Okay? So that's really a nice way for us then to divide up this application and make more agile the development of the application and the operation of that application. So we've used a few terms here, some terms that you may not have heard, right? And we still haven't really defined what a container actually is. Well, the word container in this context comes from the idea of the shipping world, the physical shipping world, where you have some manufacturing in some overseas country. And when the manufacturing is complete, all of the product that is then built is loaded into a shipping container. We've all seen these big giant steel boxes that start at manufacturing and then they get loaded onto a massive ship with thousands of other containers where they're shipped over the oceans and delivered to some port. And those containers are taken right off that ship and loaded onto a train. And wouldn't you know it, that the train has the ability to take these containers in that exact form factor right off the ship and load it onto the train. And then they get shipped all around the world or all around that country on that train, and they're delivered to a big 18-wheeler truck, where they're then shipped directly to a retail store or to market or to whatever it needs to be done, right? And all we have is this single container of a size that everybody works with. Well, when it comes time to take that analogy into the software world, why don't we build a container and put our software in that container so that that container and the software that went into it can be shipped around anywhere to any type of system? Typically, we're dealing with Linux systems here, but the more important part of this is that as applications are built, most of our applications will rely on external components, external libraries, external pieces of other pieces of software. Maybe there'll be a web browser that needs, or a web server that needs to get put into here. Maybe there'll be a database or something like that that needs to be put into this, or other types of libraries that must be there, prerequisite dependencies that must be there in order for my application to work. And those dependencies often rely on a particular version of that software. Python, for example. We got to have a particular version of our Python or our Java runtime libraries or something like that, okay? Well, if I as a developer develop on one version of Python or Java, And then I hand it off to operations, and they've got a bunch of Linux machines with who knows what version of that particular software library, then I don't know if my software is going to work. But by placing it in a container, my software in a container, along with all of the dependencies that that software relies on, and then I can ship the entire thing into operations, I know that everything is going to work just fine. So that's the idea of a container. It contains the application and any of the dependencies that that application is then going to rely upon. And I can ship that around from testing to staging to production without having to worry about whether or not that application is going to run, even when there are differences between those testing and staging and production environments. Now, in order to do that, I need a container engine. I need something that says, hey, what are the commands that I use to actually create a container? And then to be able to place that container into production and those sorts of things. Well, that's what a container engine is. It's a runtime engine that helps us to manage those containers. The most common container engine that's out there is called Docker. And many of us have heard that term and maybe even confused it with the container itself. No, that's the engine that helps us to build and manage those containers. Okay. Now, those containers actually need an operating system to run on. Right? The container itself doesn't include the entire operating system. No, just the libraries and the dependencies for the application. The underlying operating system has to be there. Once again, most typically on Linux. Well, this is what we call a container host. Okay? So this is, in our world, it's a virtual machine that comes along with all the wonderful benefits of running virtual machines that we've already talked about. But it certainly could be a physical machine as well. Okay? And VMware certainly says, hey, let's take our container hosts, we'll make those virtual machines so that we can support things like vSphere HA and vSphere DRS. And so as an administrator, what I may see are lots of container hosts running as virtual machines in my environment. Now, how is all of this stuff then orchestrated? As a developer, I want to say, hey, I need 3 of these database containers. Well, and I need 4 of the application with the UI. I need 5 of the web servers and all this kind of stuff. Well, that's where this term or this product or project, I should say, called Kubernetes comes in. Kubernetes is the #2 most popular and most active open source project that's ever been created, right behind Linux itself. And it was developed by Google initially and open sourced, and it is the orchestration system that allows us to bring our software managed in containers to production. Okay? So that's what Kubernetes is all about. And in vSphere 7, VMware has a couple of different ways to deliver Kubernetes. Okay? One of them is called vSphere with Kubernetes, where there's an entire Kubernetes engine built into ESXi itself. And then we have another one called Tanzu Kubernetes Grid, or TKG, which is a fully compliant Kubernetes system where the entire thing runs in virtual machines on top of ESXi. And for that system, you can actually use it on vSphere 6.7, okay, or vSphere 7. When we come back, we're going to have a deeper look at each of these components, right? We'll have a deeper look at containers and the container hosts and so on, okay? So we'll see you in just a moment.